So hello everyone, in this video we are going to solve another DP question based on strings, which is count encoding. Now this question is just a DP variation of the question print encodings that we did in the recursion module. If you have done that question, it would be really helpful. It would give you additional insight in this question as well, right? It's not absolutely mandatory, but it's recommended from my side that you check that video out first before jumping onto the count encodings question, right? So if you look at the objective of the question that you have over here in line number 3, can see that it says that you are required to calculate and print the count of encodings, right? You have to print the count of encodings of string str. Now, what would be string str, right? String str would be a number, right? A number as a string. So it could be 1, 2, 3, 4, 1, 2, 3, right? It could be anything. The only constraint on that number is that it won't ever start with 0. So there won't be a string which is 0, 1, 2, 3. Right? As it starts with 0, it is an invalid test case. It won't be passed, right? So the constraint is simple. It would be a number which won't start from 0. It could be anything, right? Now we have to count the encodings. What do we mean by encodings? So if we take the very first example that we have over here of 1, 2, 3, what we have is that the encodings of 1, 2, 3 are A, B, C, A, W, and L, C. Right? This is because 1 accounts for A, 2 accounts for B, C accounts for 3 accounts for C, and so on and so forth, right? Z accounts for 26, right? So for 1, 2, 3, what we have is if 1, 2, 3 goes as 1, 2, 3, we would get A, B, C, right? If 1, 2, 3 goes as 1, 23, we would get AW as the encoding, right? If 1, 2, 3 goes as 1, 2, which is 12, and 3, we would get L and C as encoding, right? These are the 3 encodings that are possible with the string 1, 2, 3, right? And we just have to give the count of these encodings. So the answer would be 3 in this case, right? Which is over here, right? We have further examples which are 9 and 3. For 9 and 3, there is a single encoding which is IIC. For 0 and 3, there won't be any encoding. It is an invalid input itself. It won't ever be passed, right? For 103, there is just a single encoding which is JC. And then for 303, there are 0 encodings, right? So when there are 0 encodings, we just have to print 0, right? What is considered is that 0, 1 is not equal to 1. When there is 0, 1, this won't mean any alphabet. This won't mean any letter, right? 0, 1 cannot be accounted as A, right? Similarly, 0, 2 cannot be accounted as, let's suppose, B, right? So that's not the case. Only 2 will be encoded towards B. So if we get 0, 2, this won't mean anything, right? This is the reason why 303 has 0 as value, right? So now that we have discussed the question, I would want you to attempt this question on your own and see where you can apply DP to this question, right? Moving forward, let's discuss the solution of the question. So to discuss the solution of the question, let's again take our sample input case, which we had 1, 2, 3, and let's try to draw the recursive tree, right? So when we did this question using recursion, what we did was, if we had 1, 2, 3 as our string as input, and if we write over here our answer, what we would do is, I would have two choices, either to take 2 of the letters from the string, question string, or to take just a single letter. So if I call from 1, which is just a single letter, I can also call from 1 and 2, which are double letters, right? So if I call from 1, 1 would account to A. So I have A over here, and the left out string is 23, right? If I call from 12, I would have L as my letter that I would get from encodings, and I would have what? I would have 3 remaining in my question string, right? Now from 23, I have two choices, either to call from 2 or from 23. And if I call from 2, I would get A, B, and then 3 remaining. And over here, I would get what? I would get A and W with nothing remaining. So this would be my one encoding, right? From here, I have just a single option to get just a single character, as the size is 1 itself. So I would call from 3, I would get A, B, C over here with nothing, right? Now if we come over here from L also, there is a single possibility if we call from 3, which is LC, and we would get anything here. So if we observe, at last we would have ABC, AW, and LC, right? Which are the 3 encodings that we get for the number 1, 2, 3. Understand? Okay, so this is how we do this question recursively. Again, the thing that we have to notice is that at every step in recursion, we are making call for a single digit or for 2 digits. I consider myself and I consider another digit with me, right? This is what we are doing in recursion. Again, the complexity would be O of 2 of n. It would be an exponential complexity, which is very expensive. So we would directly jump upon dp. If you want to look at the recursive approach of the question, if you want to dive deeper into it, I recommend that you look at the recursive the question in the recursion module, right? The question is print encoding, so it's the same question, right? So over here we would just discuss the DP approach. So the very first thing in DP that we do is assign storage and meaning, right? Second thing that we do is derive the direction in which we want to move in, and the third thing and the last thing is traversing and solving to find the answer. So the very first thing, which is assigning storage, what I would do is I would create an integer dp which would be of the size, which would be equivalent to the size of my given input string, right? So if my question string is 1, 2, 3, I would make a dp of size 3. Understandable? So let's suppose I take a bigger example, right? So for string maybe equal to 2, 3, 1, 0, 1, 1. Right? If I take this as my input, what I would do is I would count the number of I would just take the size of the string, which is 1, 2, 3, 4, 5, 6. So 6 is the size of the string. I would make a dp. I would make a dp of size 6. Let's make a dp over here. Right, this is my dp and this would be of size 6. So the indexes would vary from 0 to 5 as the size is 6. Okay, so okay, and yeah, 0, 1, 2, 3, 4 and 5. Okay, so this is my dp. Now let's talk about meaning of the dp, right? Let's draw intersections over here. What would dp of 2 mean? dp of 2, I would say dp of 2, which is over here, dp of 2 would mean number of encodings that are possible till second position in the string. So for 2, 3, 1, number of encodings that are possible is something that will be stored in dp of 2, right? To generalize this, I would say in dp of I, we would have the number of encodings that are possible till ith position in the string, right? So what would dp of 0 store? Okay. Let's see. Okay, if I erase this part, then what would dp of 0 store? Okay. If I write the string over here, so 2, 3, 1, 0, 1 and 1, right? What would dp of 0 store? dp of 0 would store the possible encodings till 0th position in the string. So what would my 2 make? Is something that would be stored in dp, right? The count of possible encodings. Can I say that dp of 0 would always be equivalent to 1? With a single letter, letter, you can only make a single encoding, right? Given as in the question, it's given that the string won't ever start from 0. That means we know that the number would be varying from 1 to 9, right? Using 1 to 9, you can only make a single encoding, of course, right? All the characters that are encoded corresponding to each of the number. So dp of 0 would always be 1. This is my base case, right? For let's discuss for dp of n, right? So what would be my dp of 5? dp of 5 would mean the total number of encodings that are possible till 5th position in my string. In my string, the 5th position is the last position, right? Till over here, which is the entire number. So the number of encodings that are possible with the entire number is something that would be stored in the last position of the dp, which is dp of 5 currently. right? So can I say that dp of n would be nothing but my answer itself? It would contain the number of encodings that are possible with the string till the position n, given that the size of my string is n itself. So for the entire string, all the possible encodings that are possible, the count of that would be present in the last position in my dp, right? So dp of n would be my answer. This is the second observation that we made. So this would be my answer, right? Okay. Now that we have discussed the base case and the answer position, we can only obviously quite evidently say that the direction in which we want to solve would be forward, right? The smaller case is over here, the bigger case is over here. Here is where we get our answer, which is the rightmost position. So we would be moving from left to right, which is smaller to greater, which is in forward direction. Okay, so the direction is also clear. Now, what we are going to do is traverse and solve. To traverse and solve, I would extend this dp, take lines over here, and I would extend this dp, and we are going to use the logic of recursion that we used just when we drew the recursive tree. Okay, so now we have 2 over here. I take blue and this, we have 2 over here. Okay. Pen, 2 over here, 3 over here, 1 over here, 0 over here, 1 over here, and 1 over here, right? And if I erase this part because we already have written that, I can get a bit lower, right? So I have to move in forward direction from 1 to 5. As dp of 0 is my base case, I don't have to evaluate it. But in any ways, dp of 0, what would be the strings that it would be? So over here, I would write the possible encoding strings, right? Right. So dp of 0 with the letter 2, right, which is b. So I would have b over here. Okay. So dp of 0 has one count, which is b itself. Now, if we move forward to dp of 1, which has 3 over here. So what does my 3 signify? What can I do with my 3? I can either consider just myself, or I can consider me and the previous number that I had, right? I can just consider myself and add myself to the string that I currently have from previous values. If I have b over here, if I just consider myself, which is c, then I would have strings as B and C. This is one possible encoding. The other possible encoding is when I consider that I would come together with the previous number, which is 2, 3, right? I can come as 23 or I can come as 3. So for dp of 1, I'm saying that there are two possibilities. It's either it comes with 3 or it's coming with 23, right? 3 just gets me C and 23 gets me W, right? Okay, so when I take 23 under consideration from dp of 1, I cannot account for dp of 0 because I'm taking 23, right? So what I have to do is I have to consider the value which is before this, currently, which is -1. Hence, we would only have 1 over here, right? There are 2 encodings that are possible. 1 if I consider myself alone, 1 when I consider the previous number with me, right? Let's move forward. It would become more and more clear if we move forward, right? So we have discussed for 3. Moving on to dp of 2, which is 1, right? What does 1 say? 1 says that I can come alone. I can either come alone if I write over here dp of 2, which is 1, which says that I can either come 1 as alone or I can come together with 31, right? I can come together with 31. 1 says, okay, 1 accounts to 0, so I can make a call. But does 31 account to any number, any letter, right? 31 is not encoded to any letter. 31 is out of bounds. Letters are encoded from 1 to 26, right? 1 to 26 inclusive. This is the range of our numbers from 1 to 26. Anything greater than or smaller than that, or any invalid number which has preceding 0 is something that we cannot account for. So 31 is something that we can't make a call with. So 1 would make a call just by itself, that is, it would attach A to all the encodings of its previous one, right? So I would have what? I would have B, C, A and W, A over here, right? So what I would have is 2 copied from here to here, right? Let's move on to 0. Let's move on to the next word. Okay, so dp of 3. Yeah, so dp of 3, what does dp of 3 say? Dp of 3 has the number 0 in it, right? 0. So dp of 3 can either make a call with 0 or with preceding value, which was 10, right? It can either make a call for 0 or 10. Is 0 encoded to any number? As we discussed, the range is just from 1 to 26. So 0 does not account for anything. So I cannot make a call from 0. So the call to just the previous cell cannot be made, right? So we can only make a call from 10. That means I can have this both and I can make call to 3. I can attach 10. I can attach what 10 symbolizes, which is J, right? I can have J added to all the possible encodings which are at position 1. What do I mean by that? I can have B, C and J, and I can have W and J, right? So 1 0, which is my 10, which accounts for J, it calls to the previous state and attaches J to at the end of all of those, right? So what I have over here is these two. So the encodings are 2, right? I cannot make call to 1 because call from 0 is not something that we can do, as 0 has no encodings, right? I hope it's clear. So let's erase this part and this part, and let's again write over here we have 2, right? Now what does dp of 4 say? dp of 4 says either I can come as 1 or either I can come as 0, right? Either I can come as 1 or as 0. If I come with 1, I would attach A to all the strings that are of length dp of 4 minus 1. So I would attach A to dp of 4 minus 1, right? So dp of 4 minus 1, which is 3. So I would go over here. I would see that we have bcj, wj, and I can simply attach A at the end of all of them. So I can have bcj and wwj, right? And this would account to 2 encodings. Now the other call that I could make was 0 1, but as we already discussed, 0 1 is something that's not allowed. 0 1 doesn't mean anything. 1 means to A, but 0 1 does not account to A, right? This does not mean A. So we cannot make a call from 0 1. We cannot make a call in double digits or in any digit when we have a preceding 0, right? We cannot make that call. So 0 1 is something that we cannot make. Now, very, very crucial state, which is dp of 5, right? What does dp of 5 say? dp of 5, put this below, right? So dp of 5 says that I can either come alone with 1. So we have 1 over here, dp of 5 is 1, or I can come with my preceding value, which is 11, right? So I can either come as A or 11, which is K, right? So I can either come as 1 or either come as 11. I would come 1 at the end of dp of 4. I would attach A at the end of all the possible encodings that I had at dp of 4. So I would call to dp of 4 and I would say, okay, I'm going to attach my A at the end of wja and bcja. So these are the 2 encodings that I get from that case. So 2 plus over here we would have K, and K would attach to dp of 5 minus 2, right? We are taking 2 values and we are calling before that. So we would call to dp of 3. So over here we would have dp of 3 plus k, right? dp of 3 is bcj and wj. So what I'm going to do, that means I'm going to attach bcj and I would add k to it, and wj and I would add k to it, right? These are two other encodings, right? So I would have a total of 4 encodings over here. And now that we have fully processed our dp, this would be my answer, the last position in the dp, right? The value at the last position in my dp would be the answer. And these are the possible encodings that we made, right? So the concept that we used was similar and exactly more or less equivalent to what we used in the recursive approach, right? We just converted it into dp, right? So this was traversing and solving. If you think about it, what we did was we handled the cases where we come over here, we handled the cases where we had a preceding 0 in the case, or when we had a single 0 in the case, right? So we could not make that call. That means I have to handle cases when I have 0 and my previous was also 0. I have to handle the case when I am 0 but my previous was non-zero, right? I have to handle the case when I am 0, I am not 0 but my preceding was 0. So when my preceding was 0, if you remember when it was 0 1, I could not make any call from 0 1, right? So when my preceding is 0, I can only make call for 1, this place. I cannot make a call as 0 1 whole, right? So for non-zero 1, I would have something like 1 0, 2 0, 3 0, right? So I cannot make call for 3 0. I can make call for 1 0 and 2 0 as they fall into the range. For 0 0, I cannot make any call. I cannot make from 0. I cannot make from 0 0. That would mean the position would only have 0 as answer, right? So there won't be any encodings that are possible when we have two consecutive zeros. Then again, the very last case, which was non-zero non-zero, which is the very normal case. Let's suppose we have 12. So we can call for 1 from 2, or we can call 12 together, right? So these are the cases that we have to keep in account, right? So let's try to code this. Let's try to code the traverse and solve. If we go to the code editor over here, what we have to take in input is a string str. So let's quickly do that, right? So scanner sc is equal to new scanner system dot in, right? String str sc dot next. Done. Now that we have a string, the very first thing that we have to do in dp is assign storage, right? What was our storage? Our storage was an integer dp of size of the string. So we have string dot length, right? So this would be our dp. Second thing that you have to do is our base case, right? So our base case, if you remember, was dp of 0 would always be equal to 1. This is because we are not getting any number that starts with 0. So any number ranging from 1 to 9 has only one possible encoding, right? So dp of 0 would be 1. Now we have to traverse and traverse and solve. Now we have to traverse from dp of 1 till n, so which is n minus n, of course. So dp of so I goes from 1 till n, this one. Now what we have are 4 cases that we have to handle, which is 0 0 0 1, 0 0 0 non-zero, non-zero 0, and non-zero non-zero. So let's talk about case when we have two double zeros, right? So when my string dot char at, right, my preceding value, which is the value before, is equal to 0, and my string dot char at my current value I is also 0, then I would have my dp of I equivalent to 0. I cannot make any call. If I have two consecutive zeros, I cannot make any call, not alone with a single zero or with double zeros, right? Simple. Then we would have a else if condition, and over here what we would do is we will call for non-zero and 0, right? We can have call for non-zero and 0, or we can even call for 0 and non-zero. Just try 0 and non-zero, right? So string dot char, and if my previous was 0, so I minus 1 is equal to 0, right? And my string dot char at current position is something which is non-zero, so not equivalent to 0, right? In this case, if I have 0 and non-zero, I could only make a single call. I cannot make a call with 0 in the number, right? So if I cannot make a call with 0 in the number, I can only make a call to dp of I minus 1, right, with the non-zero number. Okay, now the case when I have a non-zero number as a preceding value and a 0 as my current value. In this case, I would write this char at I minus 1, this is not equal to 0, and string dot char at I, this is equivalent to 0, right? In this case, I can only make a call of double. I cannot make a call of a single 0. What does this mean? This means that if I have, let's suppose a number which is 20, right? Something which is non-zero, something which is 0, right? So my I minus 1 is non-zero, which is 2, and my I is 0. I cannot make a call of single because I cannot make a call from 0, right? That is not allowed. So I can only make a call with 20, right? Another thing that we have to notice is that I can only make a call from 20 just because it was in the range of 1 to 26, right? The only double digit numbers that have 0 in their ones place and fall under this range are 10 and 20. Any other number like 30, 40, they don't fall under this range. So if my preceding value is 1 or 2, then only I can make a call, right? Because they only fall under this range. So let's write this. So take the cursor, right? So if my string dot char at I minus 1, it should be either equivalent to 1 or it should be equivalent to 2. So I minus 1 should be equivalent to 2. In this case, I can make a call of 2. So dp of I d is equal to dp of, I'm making call of 2, it's I minus 2 over here, right? This is it, right? The last case which is when we have both non-zero and zero. So I would write a else case over here. Now, when there is a non-zero and non-zero, I can make two calls. I can make, let's suppose we have 23. I can make a call from 3 to 2, or I can make a call from 23 to the previous digit, whatever it was, right? So if I have to write this, what I would say is I would call single, that is my single digit, and that call would be just dp of I equals to dp of I minus 1, right? And the second call, which would be for double, and this would be if, only if the number, I can only make a double call if the number is in the range from 1 to 26, right? Double call would be from 10 to 26 actually. 10 is something that is already handled, so it would be from 11 to 26, right? Right, numbers till 11 or 10 are already handled, so I have to just check if the number that I'm calling for is smaller than or equal to 26, right? Let's see how we can do that. So if I scroll this bit, right, so what we can do is we can convert a string. I can extract a substring out of my string, which would be str.substring, and I have to get my preceding value and myself. So the preceding value would start from I minus 1, and I would get till I plus 1, right, which is ith value, right? This would be my substring. Now this substring holds the value of my number, and this should be smaller than or equal to 26. What I can do is I can simply just convert this into an integer using the function integer dot parse int. And this would convert this substring into an integer, and this should be smaller than or equal to 26. Right? Now, when it's smaller than or equal to 26, what I can do is I can also add. So I would add to dp of I. I can add I minus 2 as well. Right? This would be my case. Okay. So we have handled the cases of 0, 0, 0, non-zero, non-zero, 0, and non-zero, 0. Right? At the end of this loop, I would have my answer. I would have my answer at dp of n minus 1, which is the last position. So if I just print this system.out.println dp of n minus 1, and if I run this, let's see if it works or not. Right? It is this. I'm getting an error. Let's see what it's about. It says that it cannot find the symbol. Right? Of course, we don't have n over here. So what I can do is I can, instead of having string.length over here, I can have a variable n which stores the value of string.length, as I'm using this again and again, and I can have n over here. If I run this, saying runtime error because of index of order bound. Right? Okay. Yeah, that is because if I have I minus 2 over here, now if I am at the very first position, right? If I am at the very first position, let's suppose my string is 1, 0, 1. I can only call for 1, 0 from this point, right? And if I call for 1, 0 from this point, it would go to minus 1, which is index out of bound. But I know if I'm calling for minus 1, I would obviously make at least one encoding, right? So to preserve this error from happening, what we can do is we can check that if my I is I minus 2 is greater than or equal to 0, right? Then I can do dp of I minus 2, or else I can have 1 over here. And the same case is something that I have to write over here. Just if my I minus 2 is greater than or equal to 0, then I can have dp of I minus 2 over here, or else I will have 1. Right? Let's run this and let's hope that it works now. And it does, right? Let's submit this for all the test cases. So it gets submitted. We are passing all the test cases. Let's erase this. So if I look back on the code, right? Simply assign the storage, write base case, traversing and solving from 1 to n minus 1. For different test cases, we make a if else block, and for 0, 0, 0, non-zero, non-zero, 0, and non-zero, non-zero, and even non-zero, non-zero, we have single and double calls. So we do that, and at the end we print our answer, right? I hope you got the error that we were getting. That was because of calling for double side when we were in the very first position itself. So if we call for I minus 2 over there, we would get a index out of bound exception. And I also hope you got why we wrote 1 over here instead of 0, right? So the very last thing that we want to discuss is the time complexity. Now we were able to solve this question in a single for loop, right, traversing through the string. So the time complexity would be O of n, right? This would be my time complexity. And what would be my space complexity? What we used was a single 1D DP array of size equivalent to n, which was string size, right? So this was also O of n, my space complexity, right? I hope you liked the video. I hope the question is clear to you, and I will see you in the next video. Please like, share, and subscribe. Bye-bye.